So continuing with redox reaction, this is our lecture number 5. Now question is, define electrode potential and discuss its types. Now what is electrode potential? It is the tendency of an electrode to lose or gain electrons. Now what is electrode? When a metal rod is dipped in its salt solution, that constitutes an electrode. For example, we are dipping zinc rod in zinc sulfate solution. It will become an electrode now. Zinc rod alone is not an electrode. Copper rod alone is not an electrode. When it is immersed in its solution of electrolyte, then it becomes the electrode. So we'll be now discussing the potentials of the electrode, power of the electrode. So this is electrode potential. What is electrode potential? It is the tendency of an electrode to lose or gain electrons. Types of electrode potentials. Number 1, oxidation potential. Tendency to lose electron. Then we have reduction potential. Tendency of the electrode to gain electrons. Oxidation potential is always written, neutral phase is written on the upper side, ionic phase on the lower side. Reduction is opposite to it, ionic phase on the upper side and neutral phase on the lower side. Since in reduction potential the ions are reduced, but in oxidation potential these are the ions which are produced from the neutral atoms. Now their relationship. Minus oxidation potential becomes the reduction potential. So minus Zn2 positive, this is 0.76 volt now. Now reduction potential, oxidation potential of this electrode, that was 0.76 volts, and when its sign is changed it will become minus 0.76 volt. So if we write the oxidation potential of zinc electrode, it was 0.76 volt. If we want to convert it into reduction potential, then this representation is likely to be changed and sign is also changed. This is reduction potential of this electrode. Now measurement of electrode potentials. For the purpose of measurement of electrode potential, there should be some standard electrode which is used, which is coupled with the other electrodes to find out their tendency to release or to gain electrons. So it is standard reduction potential. They are measured by coupling the electrode with NHE. So first of all we will discuss NHE or SHE. It is called a normal hydrogen electrode or standard hydrogen electrode. It is prepared by passing hydrogen gas through 1 molar HCl solution, a platinum foil coated by finely divided platinum is immersed in HCl solution to catalyze reaction between H positive ions and H2. This is normal hydrogen electrode. Now how it is prepared? This is a glass vessel. It is having a glass hood internally in which platinum foil is suspended, and this conducting copper wire is enclosed in a glass tube so that it should not lose electron. Here we are filling 1 molar HCl solution, and from here H2 gas is passed at 1 atmospheric pressure and temperature of 298 Kelvin. In order to measure the electrode potential, NHE is coupled with that electrode whose electrode potential is to be measured. Now if we couple this electrode with zinc electrode, then zinc has more tendency to release electrons as compared to NHE. This is the salt bridge. So this is zinc HCl cell, where zinc will lose electron, and these electrons they will be pulled by the platinum wire, where H positive ion they are accumulated and they get reduced by taking electron from the zinc half cell. So we'll be now studying the cell reaction in this couple. In this combination, cell reaction is to be seen. So this is the measurement of electrode potential of zinc electrode. Now cell reaction here is zinc first of all loses electron, changes into zinc ions. This is oxidation half reaction. These electrons they are gained by the copper H positive ions, and this changes into H2. This is called as reduction half reaction. Now these two reactions they are added together, that will give the redox reaction of this couple. So electrons are cancelled, Zn plus 2H positive changes into Zn2 positive plus hydrogen. This is the redox reaction. Now E naught value, you can say E naught value of NHE, that is H positive oblique H2, it is 0.0 volt. Since this is a standard electrode, it has both tendency to lose as well as gain electrons. So its E naught value, standard reduction potential, that is 0 volt. Standard oxidation potential, that is also 0 volt in this case. And now whatever the cell voltage seen here, cell voltage 0.76 volt was seen. It is called as the oxidation potential of zinc electrode because zinc is supplying electrons. But according to IUPAC convention, all the electrode potential they should be expressed in terms of reduction potential. So this potential will change into reduction potential. Therefore, reduction potential of zinc electrode. Now this representation is reversed and sign is changed here. This will be 0.76 volts. So this is actually the measurement of oxidation potential. We were not knowing when we couple zinc electrode with NHE, we were not knowing whether zinc will lose electron, it will gain electron. But when we couple, we saw the electron flowing from zinc electrode towards NHE. It means zinc will act as anode here and NHE will serve as cathode. So this is the reduction potential of the zinc electrode. Now we come to measurement of reduction potential of electrode. For this purpose, NHE is now connected to such a electrode which this is platinum foil. It is connected to electrode which will be accepting electron from NHE, and it is of that metal which is lying below hydrogen, whose activity is less than hydrogen. This is copper rod dipped in 1 molar copper sulfate solution. This is salt bridge which is connecting two cells internally, and here we are having 1 molar HCl. Hydrogen gas is filled from this side. This rod acts as a negative rod. This is the anode of the cell. Now what is cell reaction here? NHE will start supplying electron. Oxidation half reaction. These electrons gained by copper ions. This is reduction half reaction. Two reactions added together. This is called as redox reaction. Cell voltage in this case comes out to be 0.34 volts. This is the reduction potential of copper since it is taking the electron. So reduction potential of copper Cu2 positive oblique Co, it is 0.34 volt positive. No need of changing the sign of this electrode since it is accepting electrons from the NHE. So in this manner we coupled all the electrodes with NHE and we calculated the reduction potential or oxidation potentials of all the electrodes. They were then changed. If we measure the oxidation potential, it was changed into reduction potential, and if reduction potential was measured, it is not changed at all. And the different electrode potentials were they were then arranged in order of increasing their standard reduction value, and the series of the electrodes so obtained is called as electrochemical series. So our next topic will be what is electrochemical series and what are its main applications. After that we will be discussing Nernst equation and stoichiometrical calculations which are involved in the stoichiometric calculations in the cell reactions. So now we come to another topic, very important topic, that is electrochemical series. So we have seen the measurement of different electrode potentials. Now we come to the main part of this electrode potential, that is the applications of the electrochemical series and electrochemical series. Now question is, define electrochemical series. So answer, a series of electrodes where they are arranged in order of increasing their standard reduction potentials. E naught values is called as electrochemical series. First of all, in this series it is lithium electrode. Electrode reaction is like this. E naught value of lithium electrode is 3.06 volt. Then we have potassium electrode. Electrode reaction is like this. 2.93 volts. Then we have cesium. Then we have barium. So this is our electrochemical series where electrodes they are arranged in order of their increasing standard reduction potentials. Now in this case we get calcium, electrode reaction is calcium taking electrons from the electron giving species and its value is 2.87. So it goes on. At one stage we'll come across zinc, which is having standard reduction potential of 0.76 volt. We have left some electrodes. Then after zinc we have the nickel, iron, .44 volts. Then we have nickel 2 positive plus 2 electron, value is 0.25 volts. Then we come to NHE 2H positive plus 2 electron, H2 value is 0.0 volt. Now positive values are started. Copper electrode takes 2 electron, changes into copper, value is 0.34 volts. Then we have silver after some gap. Electrode potential is 0.80 volt. In the end we have fluorine electrode. F2 takes 2 electron here, changes into 2 fluoride, value is 2.87 volt. So this is our electrochemical series where different electrodes they are arranged in order of increasing their standard reduction potentials. So this series of electrode is called as electrochemical series. In the next lecture we will be studying the applications of electrochemical series.